Hi guys, it's Mrs. Mellison. Okay, let's do the check you understand on page 375. Okay, last one for this chapter. Let's see. New Jersey Transit claims that an 8 a.m. train from Princeton to New York has a probability of 0.9 of arriving on time. So that's good, 90% chance. We'll assume this claim is true. Find the probability that the train arrives late on Monday, but on time on Tuesday. So again, whenever I have a series of events, I always think of a tree. Okay, so we'll do Monday. It'll either be on time or late. Okay, so there's a 0.9% chance the train will be on time, so it's got to be a 10% chance it'll be late. Okay, and then we'll go the next day, Tuesday. It's either going to be on time or late, depending, if it was on time before, or on time and late. Okay, now it didn't tell us that Tuesday's train is dependent on Monday's train, so we're going to assume they're independent, and you're usually told if events are independent. Okay, but we're going to assume they're independent here. So what's the probability the train arrives late on Monday? So there's late on Monday, but then on time on Tuesday. So I want this part of the branch. Okay, so I just want 0.1 times 0.9. Okay, and that's 0.09. So there's about a 9% chance that the train will be late on Monday and on time on Tuesday. Okay. Now for number 2, it says, what's the probability that the train arrives late at least once in a 5-day week? Okay. Now I could draw a tree for 5 days. I could keep going. Wednesday, on time late, on time late, on time late, and Thursday, on time late, and so forth. Okay. But I want the probability the train arrives late at least once. Well, every single one of these branches, if I went Monday, Tuesday, Wednesday, Thursday, Friday, every single one of these branches is going to have at least one late train, except for the top branch where they're all on time. Okay, so I'm going to use my little shortcut. The probability at least one late should equal 1 minus the probability of not late, okay, to the nth power. Okay, so how many times? So what's the probability of not being late? 0.9, and I'm talking for 5 days. Because this 0.9 to the 5th power represents Monday, Tuesday, Wednesday, Thursday, and Friday all being on time. That is the only branch in our 5-day tree that doesn't have any late trains. Every single branch has at least one late train. So all the branches add up to be 1 for a total probability of 1. So if I do 1 minus the top branch, I'm going to be left with all these other branches that have at least one late train. Okay, so I stick that in the calculator and I get 0.4095. Okay, so approximately a 41% chance that throughout a 5-day week, the train's going to arrive late at least once in that 5 days. Okay. Okay. We got one more question. One more question. All right. Government data shows that 8% of adults are full-time college students and that 15% of adults are age 65 or older. If we randomly select adult, is the probability that they're a full-time college student and 65 years of age the two values multiplied together? Well, in our notes, remember when we multiply the probabilities together, okay, to get the probability of A and B, we are assuming that events A and B are independent. Okay, we're assuming that they're independent. That's how we got our branches. Okay, of course trees can be dependent and independent. Okay, but this is assuming that being 65 and older and being a college student are independent. Well, I don't think they are. I think knowing that somebody is a full-time college student is going to lessen the probability that they're 65 and older. Okay, so I would say these events are definitely dependent. Okay. Okay, so events are dependent. Again, they're dependent because knowing that somebody's a college student is going to influence the probability of whether they're 65 or older. Okay, I hope that was helpful. See you next time.